Hello everyone, welcome to our DCIM demo. Once you log into the platform, you will be taken to this screen where you have a map showing your various geographical locations where the facilities are located. Here we select Mumbai, which shows us the different customer facilities within Mumbai. The buildings are color-coded so customer can quickly understand if there are any possible alerts that might be present in the underlying systems. You can notice that Building 2 is highlighted in red depicting an alert upon clicking on the building. We get a view of the different floors of the building where we can notice that there is an issue with Floor 3 total power distribution unit reading. Upon clicking on the PDU value, the application takes us to the equipment causing this alert, in this case the server hall which has rack G16 that is highlighted in red. The total power being utilized by rack G16 is 1200 causing this alert. We can also notice a temperature alert which when clicked on shows that the rack A3 has a temperature reading of 28 degrees which is too high and is causing this. The idea during the development of our DCIM module was that within 3 clicks, the user should be able to reach to the source of the problem and understand the issue. To the right, we have customizable area which can show floor details in real time that the end customer might be interested to see. Next step in understanding this anomaly is to find the root cause for which person operating needs to know source of power that is being fed to the rack G16. For this, we have already integrated the single line diagram data of the particular rack which the user can understand in a glance. We can also sort the server racks based on the customers assuming that data is already updated in the DCIM. Here, by selecting the customer, the DCIM module will show only those racks belonging to the particular customer, thereby making it easy for the user utilizing the DCIM interface. Now that we know the rack G16 is the cause, we can click on the power reading, which further takes us one more level down to the reading trends for G16 from its historical data. On the left, you have the cross-section view of rack, showing the different servers placed with color code, displaying the ones with power consumption based on the set threshold limits. The ones in green are performing as expected, whereas the yellow and red ones are in warning and alert states. You can also see the properties of that rack, which is again customizable to display the data which end customer wants to see relating to that rack. Towards the right, you can see the trend map for the PDU and UPS panel that the rack draws power from. User can easily notice that the issue happened today is a common problem for this rack, which helps user identify that this could be an issue with design parameters against actual utilization capacity of the rack. Our application can further drill down from the rack level onto the server level, provided there is integration done with the DCIM, giving it inputs as to what is the make, model, dimension, size, etc. of the server. Here, a user can even take these inputs and compare it with another server if they have similar model within the facility to identify any anomalies. Our application also has dashboarding capabilities, which comes in handy for the end user to identify the energy as well as capacity utilization of the facility. Here we have an energy dashboard, which can be custom built as per the look and feel requirement the customer. In the demo here, we have added an energy comparison chart so that the user can check energy consumption of the same facility in 2 different time range, giving an idea as to when and where the consumption is exceeding in. Comparison. To the right, we have energy forecast of the building if being operated in current manner. Red indicates higher consumption and green indicates lower consumption compared to last month. We also have different visualization charts available, as you can see, for feeder comparison, as well as ability to add cards which could display KPI values for the end user. Further down, we have the savings and consumption dials, showing the energy savings compared to last month, also further break down on floor-wise savings. We can see that floor 1 to 2 and 5 are positive, whereas 3 and 4 are negative compared to last month. Monthly consumption can also be drilled down to floor levels provided the building has sub-metering. We also have a hotspot chart, which can be utilized to identify the days or months where the consumption was higher. Blue color shows comparatively lesser consumption, and red gives higher with range shown in the scale. This data is displayed floor-wise. On the right of the dials, we have line charts showing monthly PUE values of the data center as well. If the customer has multiple buildings, our application has a feature that helps user to compare one building with the other. Here you can see the energy comparison chart as well as energy forecast chart, with difference being this one is for the overall consumption of the buildings together. We can also create dials for overall savings and overall consumption as before, or if the customer wishes to have something entirely custom to display their key performance indicator, that can be accommodated as well. You can see the building-wise PUE chart on the right for the last 12 months being displayed. Down below, you have a pie chart again displaying our application's various visualization capabilities to show how much of energy was spent on each of the verticals or subsystems. Same thing can be extrapolated to costs as well based on the calculation provided so that the actual or expected costs can also be displayed in the dashboard. Now let's take a look at the capacity dashboard, which gives us an indication as to how much of the facility's total capacity is being utilized by the user currently. The first widget here shows the current floor capacity available versus utilized. You can see in the green bar, yellow is the utilized space, thereby showing that the facility has a lot of unutilized space. Next, we have capacity details of the transformers that are feeding power to that data center. Here, the maximum demand limit for the transformer is marked at 2,500 kVA. However, the maximum any of the transformers have reached is less than 1,500 kVA, that is only up to 54% of its capacity. Down below on the left, we have maximum power capacity month to date being indicated by the green bar and orange being its utilization. One can easily note that floors 1, 2, and 3 are using above 70% of their available capacity. We also have widgets showing the DG run hours in last 30 days, total fuel stock available, and the amount of backup hours. Down below, we have widget to show maximum HT load in last 30 days against the contract value as well. Similar to Energy Dashboard, we have Overall Capacity Dashboard that can be used to compare the capacity utilization between the different buildings. Here we see the pie chart showing the cooling requirements in tonnage of refrigeration between each of the buildings, giving a comparison. We also have the average HT load for each of the building against the contract value widget. Further, for any details, sales-related inquiries, demos, or requirements, feel free to reach out to our sales representatives or to drop an inquiry in our email or website mentioned in description. Thank you for your time and have a great day.